Thanks, Vivian. So thanks for joining today. We're just going to go kind of over a whistle-stop tour over BIM and information management in the built environment. So firstly, a bit about me. As Vivian said, I'm Dean Douglas. I'm a researcher at BIM Academy. I'm also working towards my PhD at Northumbria University, looking at digital twin applications. And my kind of background before that, I started off with my bachelor's in architecture, and then also moved into the construction project management space as well. And then a quick bit about BIM Academy. So BIM Academy is based in Newcastle with kind of satellite offices around the UK and a couple globally in the likes of Melbourne, Hong Kong, and Vancouver. And we seek to bring together kind of the best industry practice and the kind of latest academic research to kind of provide our unique consultancy offering in the built environment. I kind of like to start off today with a brief history of information management in the built environment so you can better understand what we are doing and why we're doing it. So starting off at the very beginning, I think we're all familiar with the kind of good old days when it was all pencil and paper, when they were king, and drawings took days, if not weeks. And the same kind of time frame for any kind of revision or rework being done. And they produced these beautiful rolls of drawings. And that was fine for a time when meetings were done in person only. The landline was the only means of distance communication, and hard copies were sent in the mail. But that gave way to reality in that every bit of project information, whether that be the design information from architects, engineers' drawings, MEP, were all in reams and rolls of paper that would quickly mount up. And because of the ever-growing mountain of paperwork, things can get lost or even conveniently get lost. And that would mean that the most up-to-date drawings may not be being used on site, or other members of the design team might not be working off of the latest designs. And this kind of lowered the potential for maximizing the value from a project. And what do you do with this mountain of paper? You try to keep it in some sort of filing structure, but someone takes something out and doesn't quite understand this kind of unique project's filing structure, and from this project, and then they just place it back in where they think it's meant to go, and over time this sort of problem continues until the information that you do hold about your asset is unmanageable, unsearchable, and pretty much redundant. And in the operation and maintenance phase, it becomes just simpler, cheaper, quicker to commission new work rather than scour through reams and reams of paper. But then we start to adopt new innovative ways of working, and out with the kind of old manual hand working, and into the kind of 80s when we start to begin to adopt various means of streamlining the processes of design, construction, operation, and maintenance. With the introduction of CAD, which I'm sure we're all familiar with now, which cut down revision and rework times dramatically, providing greater accuracy than ever before. But it still involved a great deal of hard copies, printed works, and there was also other technical advances being implemented here that meant that hard copies just weren't as effective. With the likes of mobile phones, the internet, emails, digital file transfers, ranging from floppy disks in the good old days to USB drives and online transfers now, this traditional means of information sharing begun to creak a little. And we continue to develop CAD, and it continues to evolve with ever greater operability, functions, and abilities to generate detail and insights into the buildings that we're creating. We began to model our buildings in 3D, allowing us to better understand, visualize, and communicate what a building may look like, its massing, its finishes, how it relates to other buildings. But this was still more often than not was created and used in a single discipline and lacked the properties or the depth of understanding of an asset. And again, the reality is, while elements like accuracy, production time, and information sharing were improving, we were still reliant on paper hard copies being sent to site and other members of the design team then creating their own work off the back of paper copies or digital transfers in this traditional working process. And despite means of communication greatly improving and collaborating, working was still limited, and coordination still followed pretty much the same processes as it had before when we were drawing by hand. And again, we still left with this mountain of paperwork at the end of a project. Now, with the odd spindle of CDs and pack of USB sticks, that would still be tucked in the same mountain of paperwork left to gather dust, because it still lacked a maintainable structure to the storage and the inability to quickly search for accurate information. But we still continue to progress. Advances in computing bring us the likes of parametric design, enabling computer programs and scripts to take up some of the manual working that we'd done previously and produce designs that would have taken teams of designers and engineers weeks, if not months, to produce in the past. With this being adopted by some of the world's most famous architects like Zaha Hadid, Frank Gehry, Calatrava, to produce some of their most iconic, unmistakable buildings. Well, this finally brings us to today, and where we're beginning to talk about BIM, finally in a BIM webinar. Now we look at not only the geometric information that we produce during the design and construction from each discipline within the design team, but also we begin to populate that with all the non-geometric data that is produced, such as material types, its properties, lifespan, who produced what information, when, and is this the most up-to-date version of the data? The data that can be integrated is vast, but most importantly, the data is linked directly to the geometric representation, making it easier to search, find, or locate relevant information. With that whistle-stop tour of information management in the built environment, we can finally talk about BIM in further detail. So we'll start with its most simplest of breakdowns, and we'll just take down its acronym. So buildings, I'm sure we're all aware, can be just referred to all built assets, from schools, universities, hospitals, stadiums, to housing estates. This is a boundary of BIM that's being pushed further and further to include all manner of built assets, such as road, rail, infrastructure assets, utilities, oil rigs, mines, bridges, you name it. I'm pretty sure we can apply BIM to it. And then looking at the information, this is every piece of information that we create about an asset, whether it be geometric data, design data, engineering services, construction methods, maintenance regimes, finance information, warranty, anything that's relevant to a built asset that would be beneficial to understand for the stakeholders. It's value to have it in the BIM model. And finally, modeling. This is simply the process of how we represent the information regarding our built assets in a combined, searchable, maintainable, and sustainable way that ensures that we get the most value of the information that we're already creating. I think it's really important that we kind of shake off some of the misconceptions around BIM, and we need to kind of clear them up right away. The first is that it's not a panacea. It's not going to solve every design problem. It's not going to mitigate every revision that's necessary in the construction phase, but it does have the potential to limit the effects of these problems and to make some of them highlight some of them earlier in the design project. Sadly, there's no magic wand or 3 wishes that we can call on. It's not just a 3D representation of a building. The BIM models are populated with all manner of information I've already touched on regarding the design, construction, maintenance of an asset, and it's not just a block work model. Also, it's not just Revit. Let's get that clear right away. BIM is an information management methodology, to give it its right name. That can call on a multitude of different software packages that offer a variety of functionality and abilities. It is no one software. It's most definitely not just for designers. The BIM process, for the BIM process to achieve its full potential and enable collaborative, coordinated design teams, then it relies on every member of the design team to be involved to the same level. And sadly, machine learning, artificial intelligence are still miles off of replacing us and replacing human thinking. And while BIM may allow us to automate the simpler elements and to analyze the information that we create, it's no substitute for human thinking. There's this kind of simple mantra that BIM follows, in that it strives to provide an integrated digital process, providing coordinated, reliable, and shareable data throughout all project phases, from design through construction and into the operation phase. And that's simply all we want to do. Simply, I guess. And then we can begin to look at what's at the core of digital twin, of BIM, and it's data. In BIM, it's all about the data. It's data that we already produce as part of the design, construction, and maintenance phases of building life cycles, but it's now just ensuring that the information garners the greatest value it can, promoting the collaborative processes of data production and ensuring the streamlined sharing of data, while providing standards, schemas, and for information naming, file structures to ensure that ease of that data retrieval and data searching. And if we keep thinking about how we share information in the throughout an asset's life cycle, we can look at the more traditional methods versus the BIM methods. So if we look at how BIM changes how information is shared amongst the building stakeholders, on the left we can see the traditional sharing methods, where each individual party was responsible for sharing their information that they produced throughout the entire team, leaving plenty of room for missed emails, miscommunication, stretched and stressed communication lines. Whereas on the right, you can see that BIM introduces the concept of a common data environment, or a single source of truth for a project, where all project stakeholders are able to contribute to a single repository and that is shared throughout. This repository of asset data, so they are only responsible for their contribution to that repository. This also ensures that team members are working on the latest versions of information produced by the rest of the team. And hopefully you can begin to see the impact this would have on the processes of designing and construction of a building, Gone are the linear processes of a single discipline creating a set of drawings. It's then shared to the next discipline, which adds their work in on top, and that kind of line continues to pass on from discipline to person and so forth. We're now looking at a kind of simultaneous working where multiple stakeholders work on a stage, a building stage at one time, continuously updating and coordinating their designs on a far more regular basis. And BIM offers a great deal of benefits. It's not just during the design stage. BIM offers, sorry. With this great wealth of information and ability to work and go further with collaboration and cohesive environment that we create with the BIM methodology, we open the door to a multitude of benefits, such as better design coordination, reduced design risks, reduced construction waste, less time documenting, more time designing, construction program reduction, and it opens us up to greater integration of new technologies like modern methods of construction, utilizing offsite prefabrication, sensor integration for design evaluation and better understanding of the consequences decisions in the construction phase have in the operation, the kind of tracking of plant usage during the construction phase as well. And I think it's also important to remember here is, and I've kind of touched on this, is as we begin to broaden the horizons for BIM and the kind of applications of BIM become broader and broader, it's beginning to outgrow its own meaning. And instead of thinking of BIM as just building information management modeling, we can instead think of it as better information management and how we maintain and continue to increase the value of the information we create. And I think it's important that we quickly touch on standards. I won't dwell on it too long. I know that standards are a quick way to send people to sleep, but we're really fortunate in the UK to be one of the countries at the forefront of BIM development. And one of our contributions to this so far has been the development of BIM standards. Originally named PAS 1192, the suite of documents provided a structured means of implementing BIM. But since then, those same documents have been turned into a suite of international standards for the implementation of BIM, an achievement that the industry is really proud of. This also means that the standards that the UK construction industry have been working with since around 2014 are now being applied around the world, with BIM Academy working on projects already in the likes of Hong Kong on public buildings, in Qatar on civil infrastructure, in Germany on manufacturing facilities, and in the UK on a variety of projects and built assets. We were even fortunate enough to be involved in one of the first certifications of the international standard in Central Europe, working with SEI in Hungary. And to give you a kind of a small flavor of what the standards really seek to introduce, is to simply help organizations implement BIM. But outside of that, we can take a look at the information requirements, which are at the core of BIM development and of course, the BIM standard. And in a nutshell, all we want to do with the information requirements is ensure that everyone is on the same page, everyone understands the same requirements in the same way, and we don't end up with multiple interpretations of what a client wants from their project. And to show you what the standard begins to look like, the standard sets out 6 stages of information requirements, building and delivering, ensuring that the client is able to express their requirements clearly, concisely, and in an understandable manner. Pulling away the jargon, the acronyms, and in their place providing plain language with clear definitions so that all involved better understand the role they play in a project. What information they are expected to create, to what standard is to be created, and what granularity is to be delivered, and when it's to be delivered are all part of this information requirement. So right, the standards part is over now. I won't go too much further, and we'll start looking at the benefits of BIM. So one of the kind of key phrases around BIM implementation is starting with the end, or beginning with the end in mind. And this is simply understanding the implications of our actions and decisions in the very outset of a project, and through the design stage and how they affect the whole life cycle of a project, through the construction and into the operation and maintenance, and right through to the end of life, and how we retrofit, repurpose, or demolish an asset. As I already touched on as well, the development of a single source of truth in that common data environment and how we share information creates this wealth of information in a single data repository, accessible to the design team as well as the operations and maintenance staff that houses this asset information in a structured and searchable way, removing a lot of the friction and confusion and reliance on reworking and manual processes for data retrieval, which in turn enables better informed decision making from having more data at hand quicker than ever before. We can also begin to mitigate site risks before we even get on site. We can begin to understand the difficulties in the specified construction methods and what the teams on the ground will face before we get there, and implement new measures to mitigate that and reduce that risk. Similarly, we can begin to limit the amount of reworks that are necessary during the construction phase through better coordination and collaboration during the design stages, and an understanding of how different design discipline elements come together. We can better understand where the clashes are and begin to mitigate them before they become a problem. And this has clear implications for cost and time overruns being reduced on site. Then looking into the construction phase. Similarly, on site during the construction phase, contractors and engineers and on-site staff have access to the most up-to-date, accurate information, more information than they've ever had before. They can also communicate more effectively and efficiently with the technology that BIM processes allow them to adopt and integrate, keeping enabling them to communicate with on-site issues. So using such technologies as tablets to relate photographs and relating them to a BIM model, and also relating them to the progress of works and its implications. And then we go into the operational phase, the longest and most costly phase of a built asset's life. And there's numerous benefits here, but to try and take it down to just a few. We can then provide facilities managers and operational staff with visualizations of systems, allowing for faster and more accurate tagging of assets or maintenance of assets, and begin to streamline their own processes. The time and effort of finding related documents and to of documents and information to perform work orders is reduced because they now have a wealth of information at their fingertips that they can search through and relate to a particular place in a building. Integration with building management systems and building automation systems, allowing for greater visibility into the energy efficiency by comparing comparing as built versus as operated data received from the system, internal systems. And the integration with maintenance management systems, providing maintenance teams with greater information regarding work orders and allowing them to make better decisions through being better informed. One such project in the facilities management space that we've been involved in is the facilities management and operation phase of the Sydney Opera House, a project that's kind of the jewel in our crown. But it also embodies a multitude of the problems and issues that are commonly faced in projects. It's owned and run by a public body using taxpayer money. It's a large-scale asset that costs millions to run and maintain each year. And in its wake, it had a plethora of outdated facilities management systems that were disjointed, unlinked, and unable to talk to one another. But through the use of a BIM model and the integration of building management and facilities management systems, we managed to realize operational and cost efficiencies, all through the better availability and use of data that they already had. And hopefully this works. Just a quick video to show you how we put this together. So the facilities management teams are actively using the BIM model to manage and operate their estates, their preparation for events, their maintenance of fixed assets, and they're also able to pan around the building, understanding where problems are, where bottlenecks are, where assets should be, and so forth. We can begin to pan around the accessing other documentation that already existed around the building. Hard copies that have been taken into digital formats can all be integrated into the BIM model. And conscious of time, I'll keep going. But it doesn't just stop with BIM. BIM is a long journey of implementing information management that opens up numerous other doors to technology integration and analyzing and understanding our built assets better. Some of the projects that we are involved in at BIM Academy are the likes of sensor monitoring of assets. So we integrate humidity sensors, air quality sensors, heat, electrical usage. We can begin to understand what the implications are of our changes to environments to ensure that occupancy comfort is maintained and that buildings are heated and cooled in a way that makes them the optimum for their use, and also saving energy. Aquila is another one of our projects that looks to monitor and analyze on-site plant equipment. On-site plant equipment utilization, ensuring the equipment downtime is minimized, equipment provision is accurate to a project, and we can begin to share plant equipment between sites to reduce cost. We also are developing a digital twin framework. We already have kind of one eye on the future of BIM, and we want to understand what the connections between BIM and digital twin will be in the future, and how can we be at the forefront of that development. We also have SmartForm, which looks to better understand curing times for on-site poured concrete during the construction phase. And I think potentially the bit most of you tuned in for is what's the benefits to you specifically. And I might be a little bit biased because, I'm already in this career, but simply it makes you more employable in the built environment. The adoption of BIM is ever increasing. It's already mandated on all public sector jobs in the UK, and that already accounts for a large portion of the UK construction industry. So to have that knowledge straight out the gate makes you already a more desirable candidate. More and more companies are asking for BIM specialists, BIM practitioners, BIM project managers. There's a multitude of BIM roles that are out there. And they're becoming integrated into existing organizations and clearly into almost every aspect of the built environment. There was even an article recently, as you can see on the screen, on earlier this year on Arc Daily that said architects are turning to BIM for better careers. It did also say you got better wages, but I'd maybe take that with a pinch of salt. It also opens you up to a lot more opportunities. The diversity of projects, a lot of projects you might never have imagined yourself working on. And also changes the manner in which you may contribute to these projects as well. As I mentioned earlier, there's global potential for the application of BIM. As I said, UK is one of the countries at the forefront of this development, meaning there's lots of untapped BIM markets out there. Also, there's the opportunity to work with numerous new and innovative technologies and working processes, whether it be the integration of sensor technologies, the application of the Internet of Things, or the development of digital twins. They're all exciting avenues that can be exploited from BIM. So what could be the kind of next steps if you want to learn more about BIM? Well, you can contact us. We offer teaching resources. We have virtual projects that we run. We have learning and development courses, webinars, podcasts, articles, all out on a regular basis that you can access, a lot of which for free. And also just get in touch. And as I say, and beyond us, there's numerous articles out there, both from academia and in industry, around the applications of BIM. You can begin to understand the process. I can also finally give you some of the lessons that we've learned at BIM Academy in the past 10 years of applying BIM, and hope that you can take some of them away and learn from them and hopefully apply them as well. So one of the ones I like the most is always question why a process is the way it is, especially if it seems convoluted and time-consuming, repetitive. And if the answer you get back is just because that's the way we do it, then there's an opportunity for a fix. There's an opportunity for that to be reviewed. It's also not just about buildings, and it's not just about architects and designers. It's the whole design team being involved in the collaborative design process on just about anything. As I've already said on numerous times, the BIM methodology can be applied to just about anything from buildings to roads to rail to mines to factories. And it's not just that design construction phase, it's throughout the entire lifespan of an asset. And BIM isn't just a process shift, but it's also a cultural and behavioral change, and we definitely shouldn't fear it. Just like to say thanks, and if you have any questions, feel free.
Thank you so much, Stephen. That was great. Really interesting stuff, and I think our users will find that incredibly useful. I'm not sure if there's any questions in the chat at the moment. It doesn't look like it. One thing I wondered was if you guys are working with an organisation that isn't employing the BIM methodology, what are the sort of challenges in trying to get people to adopt it? Are there any particular things that are a challenge?
I think, as I said, it's first of all, it's realizing the value. Most of the organizations that we work with are applying BIM for maybe only the first or second time. You know, there's a lot of public bodies that may be involved in the process, but they're not familiar with. So it's about educating the benefits, realizing that this information is being created anyway, and we should seek to get as much as we can from it. We're already paying for it, especially when we're talking about it in a public sector terms. So we should definitely seek to get the most from it. And that's kind of BIM at its core.
Yeah, utilising everything that's already there.
Yeah.
Dean, can I ask a question about the process of implementing it? Have you found that the process of getting an organisation to adopt a BIM system of any sort is challenging, is difficult, is expensive? Is it how does it work? Is it okay?
I'll pick up on the first one that everyone hears right there, and that's the cost element of BIM. There's no proof that it costs more, really. As I say, we're not asking for more information. We're asking for the same information in a standardized format. We're going to follow this structure and schemas of information. And actually, there's probably more articles that look at the benefits of it. So we begin to reduce reworks through design coordination at a much earlier stage. So actually, that cost of rework is much cheaper because we're not physically reworking a built asset. We're just changing it in a model.
Okay. So actually, the cost of any implementation costs do pay off fairly quickly, short term.
Yeah, and this is the other thing that we're always keen to push as well, is that if that's the design construction phase, there's also that whole operation and maintenance cycle of the life cycle, and that's where the real value is. So we're already getting value in the design and construction, but what we're taking into the operation phase is better information, and if we can learn to integrate that into our management of our facilities, then we're already gaining even more value for money from what we've procured.
Yeah, I see. We have a question from Duncan here. Is there a crossover of BIM with traditional GIS software? Or another way of asking, does BIM integrate well with GIS?
So this is actually an area that we're looking at, and it's kind of what brought BIM Academy and Digimaps together. Traditionally, no. we grew up in two silos doing very, very similar things, and we're now realizing that there's more overlap, and there's a lot more study going into how we can better integrate those. I wish there was a simpler answer. I think as we go forward and look at things like digital twins, then we're going to need to better understand this relationship between GIS and BIM. But there's definitely synergies and there's definitely overlaps.
Yeah, it sounds like a complicated question.
Can I ask something else, Dean?
Yeah.
For students, you gave some tips there. If a student wants to, leave with their degree and also be able to sort of note some BIM skills, are there routes to doing that other than very expensive courses? Are there things they can do in their placements, in their assignments to help?
You can definitely petition your lecturers to ask more and integrate more BIM knowledge in. As I say, like a lot of employers are looking for it now, so and there's not a great deal of especially undergrad courses that offer in-depth knowledge of BIM. So if you can begin to do that reading and understanding maybe some of the aspects, kind of overarching principles, as I mentioned, the standards suite. You don't need to know the standards to a T, yeah, don't question me on those, because I don't think I could answer half the questions, but it's understanding how these documents relate to one another. There's lots of opinion pieces on Twitter, on LinkedIn around the kind of the BIM environment, and kind of opinion pieces. There's BIM Plus online that talks about BIM every day.
Okay.
You can all get involved in.
Great, thanks, Dean. I'll prompt you to send me some of those networks, and I can share those in the follow-up as well.
Sure.
So I don't think we have any more questions. So I think all that remains is just to say a huge thank you to Dean for spending the time with us to cover the BIM webinar. Really much appreciated, Dean.
No worries.
Really valuable.
Thanks for
Thank
having
you.
me. And as I say, do feel free to get in touch if you have any questions or anything in the future, or just want to know a bit more.